Starting in 3. Hello, my name is Beth Dixon, and this is a review for Math 1830, and we're starting on some review chapters, and this one is Chapter 0, Section 4, to rewrite expressions changing from radical form to rational exponents or vice versa, and to perform some operations with radical expressions and expressions with rational exponents. This again is one of the most vital of these sections that you will review, and as she puts some of these forms up, they will be really hard to understand in their mathematical form. So I'm going to give you a couple of examples that we're going to do with numbers. Basically, this first one is what we're really doing in this section. And you may or may not have seen this before, so this is very important. First of all, let's look at the square root sign. A square root sign, or a radical sign, indicates that we're taking the square root. Without a number there, there is an understood number here. So in other words, we have an understood 2. We can also take a cube root with a radical there and have a 3, or a 5th root and put a 5 there. So all of those are things that we could do. If we have any number that we want there, and that means that we're taking that root. In a square root, it would be the number of, we're looking for the number that multiplies by itself 2 times. A cube root would be the number that would multiply 3 times to give me what's inside. A 5th root would be multiplying by itself 5 times to give me what's inside. So if I'm looking at the square root of 49, of course that would be 7, because 7 times 7 is 49. If I'm looking for the cube root of 27, that would be 3, because 3 times 3 times 3 is 27. If I'm looking for the 5th root of 32, that would be 2, because 2 times 2 times 2 times 2 times 2. 2 multiplied by itself 5 times gives me 32. So when we do this as well, we can also see now that we have a power. Well, what happens if we put a square root and then an x to the 3rd power? Well, we can rewrite that a couple of ways. You can rewrite it with the power inside, or it can be rewritten with that squared here and then that power on the outside, and those both mean the same thing. It doesn't matter whether the power is on the outside or whether the power is on the inside. And so if I have x squared to the 3rd, or the square root of x to the 3rd, or the square root of x all raised to the 3rd, that actually means the same thing. And both of those can be written as x raised to, and then we write that as a fraction. And the key here is the power goes on top and the root goes on the bottom. So with my example, the square root of x to the 3rd, that would be to the 3/2 power. So up here where I have x to the m over n as my rule, that would be x to the m over n. M is your power, and n is your root. Where is the root of a tree? It's on the bottom. So if we've got the cube root, the fifth root, the square root, where is the root of a tree? It's on the bottom. So it goes on the bottom. The power of a tree comes from the sunshine. The sun is up on the top, so your power comes from above, so it's on the top. At least that's the way it was explained to me as a way to remember it, so that's how I remember it. So that's what that rule says. Let's look at the next slide. So we have the square root of x can be rewritten as x to the 1/2. And that is because there is an understood root of 2 and x has an understood power of 1. So you want to think of the square root of x as x to the 1/2 power. 1 being the exponent and 2 being the root. 1 being your power, 2 being your root. So it goes, the 1 goes on top, the 2 goes on the bottom. If I have the cube root of x squared, that would be x raised to the 2/3. The 2 goes on the top, the 3 comes down on the bottom because 3 is your root, 2 is your power. So if I have the function of x, or f of x, equals 3 times the square root of x, how would I rewrite this using rational exponents? By rational, I mean using number exponents and not the little symbols, which we call radicands. So I would rewrite that as 3, and then the square root of x is written as x to the 1/2 power. So f of x equals 3 times the square root of x is the same as 3 times x to the 1/2 power. Our next problem is g of x equals 5 times the cube root of x. So that would be rewritten as 5 times x raised to the 1/3 power. The x has an assumed 1 as an exponent and a root of 3. So that would be x raised to the 1/3 power. Next, we have f of x equals 2 all over 3 times the square root of x. So the 3 and the square root of x are in the denominator. The 2 is in the numerator. So when I rewrite this, that would be 2 over, I don't like rewriting that. So that would be 2 over, and in the bottom would be a 3 and an x. The square root of x is rewritten as 1/2. Now, as I rewrite that, remember the directions we had previously, which said do not leave x's in the denominator. So if I did not leave the x in the denominator, that 2 would stay on top, the 3 would stay on the bottom, the numbers do not move, it's only the variables we do not want to leave in the denominator. So then I have x to the 1/2 power. I would move it to the numerator because I do not want it in the denominator, and its exponent would change from a positive 1/2 to a negative 1/2. And so I could also write it this way. You want to watch your directions and check your answers because it depends on what the directions say. And she wasn't real clear on the directions because Ms. Moneyhan made these for me. And I wanted to explain both ways, so I took the time to do that on this example. Let's go to the next page. And now we have h of x equals the square root of x plus 2. And that means that the x plus 2 is under the square root. As I look at that, I want to remember that the x plus 2 is a quantity and under the square root. So I will put the x plus 2 inside parentheses. So that's the first thing I do. then I remember that a square root is the same as a understood 2, and it would be like a 1/2 if it's to the first power. Well, there is no power on the x plus 2, so it's like if I wrote it over here, that x plus 2 would be to the first power. If I wrote it in its original, over at its original form, I could put x plus 1 to that first power, so the square root of x plus 2 can be rewritten then as x plus 2 in parentheses to the 1/2 power. Okay, let's look at the next one. We have g of x equals 1 over the square root of x to the third. So my first step would be to leave the 1 where it's at, change the square root of x to the third to x to the 3/2, the power going on top, the number going on the bottom. And so that gives me 1 over x to 3 over 2. And because that leaves an x in the denominator, I want to take that x in the denominator and move it to the numerator. I want to take the x in the bottom of my fraction and move it to the top of my fraction. So as I do that, that means that x to the 3/2 moves to the top. That then becomes a negative as I move it to the top, and then that leaves nothing in the bottom. I could leave a placeholder in the bottom, but that's not necessary. So that gives me x equals, that gives me x to the negative 3/2 power. The next page gives me f of x equals 2 over the cube root of 2x plus 4. So as I look at that 2x plus 4, I want to remember that 2x plus 4 is a group. It's all under the cube root. So I have 2 over the cube root of the quantity 2x plus 4. I want to remember it's kind of raised to the first power, or it is raised to the first power. So really I have 2 over 2x plus 4 raised, all in parentheses, raised to the 1/3 power. And again, I'm rewriting these without, yes, in her directions. I missed it in the directions. So I am following what I thought her intent was, even though I didn't see the directions. I'm looking back at the directions. She did say, rewrite each with no variables in the radicals and no variables in the denominator. In other words, we're not going to leave anything under those I call them radicals, she called them radicals. It's the same thing. We're not leaving anything with this part right here. And so as we did that, but we don't want to leave it in the denominator. So the 2 is going to stay where it's at, and that 2x plus 4 up here is going to come to the top. And when it moves, that 1/3 becomes a negative 1/3. This is probably one of the most important skills that you will need as you take derivatives. And so derivatives is something you may or may not know what that means, but it's important as we do a real important part of calculus. So make sure that you really understand these. Okay, we have 3 more examples that we're going to do. So let's look at the next one. Here we're going to multiply. And so basically this is the same as doing our exponents, except these are going to involve fractions, which is what she calls rationals. Rationals include integers, whole numbers, 0, and fractions. So as we look at this, this is 3x squared. We're going to rewrite that x as x to the 1/2 power. And as we rewrite those, then what do we end up with? Well, we end up with needing to add our exponents. So what is 2 plus 1/2? Well, 2 would be, we wanted to have a denominator of 2, so that would be 4 over 2 plus 1 over 2, which would be 5 over 2. Well, you could say, well, it's 2.5 or 2.5 on your calculator. Well, if you take 2.5 in your calculator and change it into a fraction, you will get 5/2. So this would be 3 times x to the 5/2. Okay, our next problem is the cube root of x squared times the square root of x. So we want to get rid of the radicals first. That's the first step, to get rid of those radical signs. So that would be x, the cube root of x squared becomes x to the square of x raised to the 2/3 power. The 2 is your power, goes on top. The 3 that is your root goes on the bottom. So that's x, the cube root of x squared times the square root of x. So to change the second part, we've got x to the 2/3 is the first part. The second part is the square root of x, which becomes x to the 1/2 power. So now we're going to add 2/3 plus 1/2, and you can use your calculator to do this. I don't happen to have a calculator in the classroom, so I'm going to do it by hand by getting a common denominator, which is 6. 2/3 becomes 4/6, 1/2 becomes 3/6. So that gives me 7/6. So this gives me x to the 7/6 power. Okay, in my next problem, I have 3x squared all over 4 times the square root of x to the 3rd. Again, I need to rewrite without the radical sign. So that would leave the 3x squared on the top. Over on the bottom, instead of being 4 times the square root of x to the 3rd, that would be 4 times x to the 3/2 power. And so now we have 3x squared over 4x to the 3/2. And in this case, I'm just going to subtract 2 minus 3/2 to get my power of x. And so 2 becomes 4/2 minus 3/2 equals 1/2. And so that gives me 3/4 or 3 over 4. And then the x gets a 1/2 power from where I subtracted my exponents. So that's 3 over x to the 1/2 power all over 4. And that's the answer to the last example. The homework that you need to work for this video is the practice from the textbook would be page 26, problems 7 through 16, 31, 33, 35, and 55 through 58. Thank you for watching. If you need additional help, contact me, Beth Dixon, at beth.dixon@ws.edu on the Morristown campus in MBS 222, or contact Ms. Monahan in your eLearn or your instructor. Thank you for watching.